Hello, today we are going to discuss sliding window maximum. This question does not need any description about its importance. By seeing its company tag, we can see how important this question is. See how many times Amazon, Google have asked this question in their interviews. So let's discuss what this question states. You are given an array of integer nums. There is a sliding window size of k, which is moving from very left to very right. You can only see the k numbers of the window. Each time the sliding window moves right by one position, return the maximum sliding window. Okay, what this question states is this is the example test case, and you can see the constraints are also big, so brute force is not used in this question. So let's discuss what this example test case states. Okay, so this is what the example test case they had given. Now let's discuss. So they had given an input array of nums, that is, this is the given input array, and a window size of k, that is 3. Now what we have to do is we have to traverse the given array in such a manner that for every window size, that is, for every window size of that array, we have to determine the maximum element of that. So for example, from a very left to very right, they had given in the question. So what we will do is, first we will take the first three elements as the window size of k. K is 3, as k is 3. So first we will take first k elements, and we'll determine what is the maximum element in the first three elements of that, or the maximum element in that window. So what is that? That is 3. So here it is. Now for the next k elements, means, so this would come here, right? It will shift by one position, here also, here also. So 3 minus 1, 3. So this would be the next k size of the window. Here also we can see 3 is the element that is greater than minus 1 and minus 3. So 3 is the maximum. And now coming on to this position, minus 1, minus 3, minus, that is 5. 5 is the greater. So 5. Similarly here also 5 is greater, and now in this 6 is greater, and this 7 is greater. We have to return this array as the output. I think you all understood the question. Now, what would be the brute force approach for this question? You may see that as given k is 3, right? Let me discuss in this. Okay, what is it? Let me copy this. This is the given array, right? What I will do is brute force. What I will do is I will run a for loop first, which will travels from 1 to n minus k, that is till here, because this is the last window size which it can travel, right? So we'll run a loop for I till n minus k plus 1, and then we'll run another for loop till k, right, for j till k, and then we'll traverse through the k size, and we will calculate the maximum element, whether it is maximum, like that. So it would be roughly around n square. The time complexity would be roughly around n square. Now coming on to the optimal approach. What is the optimal approach as per you? As we can see that we have to calculate for every window size. You may think there may be an approach which uses two pointers, like sliding window had, as the question given, like sliding window maximum. So you may think it would be like sliding window, but I will say why that approach will not work. Yeah, it will work, but it would be complicated. Like for example, if we take for this element, right, we'll traverse the first three elements, and we'll take the maximum element. And for the next element, like that, we'll take this element, and we'll calculate the maximum. Like we'll compare the last element, that is minus 3, and we'll compare the maximum element. And the for next iteration, we'll compare the maximum element with the 5. But here the maximum element is not within the window, and it fails for a test case. For example, if they had given 5, 3, 1, 2, 4, minus 1, 6, minus 6, In this test case, the answer would be 5, but 5 is not the correct answer. So two pointer would be failed right here. But for in order to make two pointer working here, we have to make this element and we have to calculate the maximum element. And when the maximum element is out of the window, then we have to another ones we have to calculate the maximum element, like that. It would be complex. So what my approach would be, I would use a stack here. You may ask why stack. Like I will get the next greatest element to its right, and we'll calculate whether it is in the range of the window or not. Like that I will do. Let me explain that approach. For example, okay, control V. I, I will what I will do is I will use a stack here, right? I think you all know how to calculate the next greatest element to its right, next greatest element to its left, and smallest element and largest element. It is important. You have to learn that. So if you don't know, don't worry. I will explain what the next smallest element, next greatest element to write. I will explain this, and you can other process are also same. First, what I will do is, as 7 is here, there is no other than element which is greater than 7. So I will, for simplicity, I will assign. So I will make an array of next greatest element to its right, and I will put the next greatest element of the rightmost element as the length of the array. In this case, that is 3, 3 plus 3, 6, 6 plus 2, 8. I will put it as 9 for simplicity. And now for 6, we can see 7 is the maximum element. And for 3, 6 is the maximum element for its right. We have to calculate the rightmost, that is immediate next greatest element. Not the greatest element. We have to calculate the immediate next greatest element. For 5 it is 6, for 3 it is 5, for yeah, for minus 1 it is 5, for minus 1 it is 5, for 3 it is 5, and for 1 it is 3. So this is the next greatest element to its right. You may ask how it works. So for example, in this case, what we will do is, initially for the rightmost element we will push the answer as the length of the array, and then we'll push it to the stack, that is 7. After that, we'll compare this element whether stack is not empty or the top of the stack is greater or less than or equal. If it is lesser, then we'll pop it, and we'll, until it is popped, we'll uh, pop the element. And if there are elements remaining, then it would be the next greatest element. If it is not, then we'll assign it to the length of the array. Then similarly, this is how for now in this case 7 is the greatest element, so we'll put assign 7 as the answer, and then we'll push 6 to the stack. And then for 3, we can see 6 is the greatest element, so we'll assign 6, and we'll, as it is not the greatest element, we have to push it to the stack. And then for 5, it is not, we'll pop it, and 6 is the greatest element, we'll assign 6, and we'll push 5. And then for minus 3, 5 is the greatest element, we'll put it 5, and we'll push minus 1. And we can see minus 1 is smaller, so for minus 1 we'll pop minus 3, and 5 is the answer, 5. Then we'll push minus 1. Then 3 is greater than minus 1, we'll pop minus 1, and then 5 is there, so we'll push 5. And then for 1 also, we can see, we'll, yeah, 3 is here. And for 1, we'll calculate whether which is the next greatest element. 3 is greater, we'll put 3, and this is how we will calculate the next greatest element to its right. And now you may ask, how will you do the, like, how will you solve this question using the next greatest element of to its right? What I will do is, I will, rather than storing the element, I will store the indexes of the element. In this case, for it's 9, so I will store 9, and here it is 8, here it is 7. Oh, wait a minute, it is 0 based indexing, right? It is 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3, 3 plus 3, 6, 6 plus 2, 8. Yeah, that is correct. Now, I will check for each element, will traverse the array for each element whether this element is within the bound of the window what I am searching. If it is there, I will put the answer. If it is not there, then I will go to its index. That is, if it is example, in this example, in the next case for 2, we'll check which is the greatest element. Yeah, we can see 3 is obviously within the bound for the next window also. So 3 is the answer. And then for the next window, as you can see, j is right, j is 1, but the window size starts from 2. So we'll calculate the element which is greater from the second element, the next greatest element which starts from the second index, that is 5. I think you all know how we can solve the problem. This is how the intuition works. So now let's code it up. This is hard question. Basically, it is not that hard. You have to know the implementations. Now, let's solve the problem. What we did, since you can see in this example, what we did, we took a stack, and yeah, we took a stack. That's all. And also to store the answer, we need a vector. Yeah, that's all. Now let's take n as the size of the given vector, and then we'll create a vector to store the result. Like yeah, it's typo. Int result of what size? N minus k plus 1. N minus k plus 1. You may ask why g1, why it is not n, why it is n minus k plus 1. You can see obviously for storing the next greatest element within the element, we will leave the last window, right? These two elements are not within the bound, because for these two elements we cannot construct a window size of k. So we'll leave that. So that is why I am doing n minus k plus 1. K plus 1 because we'll include the last element, so k plus 1. And now, yeah, result we had done what we did. Yeah, we included a stack, we had done, we took a space to return the answer. Then what? Then we'll take a stack of int type stack. Now what we have to do? After assigning a stack, we have to, like, for the lastmost that is rightmost element, we have to store it in the answer, right? So we'll store it in the answer. Yeah, for storing the next greatest elements to it, right, we have to calculate, we have to take another space, auxiliary space right here. So we will take, that is vector of int, that is next greatest elements to its right. I will, for simplicity, I will take nge, let's say, till it would be of n size. Now, let us start the actual process. What we have to do, we have to assign the rightmost element to the length of the array, right? N minus 1 would be length of the array. And then we have to push, dot push. What we have to push? The index of the last element. Now, after pushing, what we are doing is, in this we are initializing a stack. This, what we are doing here, we are pushing last element to the stack. And now, after doing this, what we have to do, we have to run a for loop for int I is equal to n minus 2. Why I'm doing n minus 2? This is because we are calculating from the last second index, because the last index has already its answer, because it is the rightmost element of the array. So there would be no other than that element which is greater than that. So we will initialize the length of the array as the largest element. And then I greater than or equal to 0, then we'll decrement I. Now is equal to, yeah, after doing the for loop, we have to iterate, right, while stack is not empty, and while stack is not empty, and the top of the stack element If it is lesser than, no, yeah, if it is lesser than, it is not array of s. It should be vector of s dot top, right? We are calculating here the index. We are storing the index of the element in the stack. So that is array, in this case nums, right? Nums of I, if it is greater than or equal to the stack, that is array of, that is nums of s dot top. If the element is greater than the elements present in the stack, then we have to pop it, right? That is, we have to simply s dot pop. After popping, we'll check whether if stack is not empty, and obviously it is the greatest elements to its right. Then what we will do, we will assign next greater of I. What would be the next greater of I? It would be the top of the stack. Else the stack would be empty. Then there is nothing we have to do. Next letter of I would be simply n. Now, after doing all this process, we have to push once again the element to the stack. It's that push of I. Now, after this is to find out the greatest element to its right. Now, after doing this, there is nothing left. We have to maintain two pointers, that is int j would be 0, and now we will run a for loop. I is equal to 0, I less than or equal to n minus k I plus plus. What we'll do is, when if I less than j, it should be j less than I, j less than I. What we have to do is, we have to initialize j to I. Else, now we will check while the next greatest element of j, there is, if it is less than I plus k, then obviously it would be the answer for that window, particular window. Then we will do, that is result of I. Result of I would be this array of j. I will explain it if you don't get it once again. And after initializing it, we will initialize. This should be done in the next part. J would be array of nums of j, right? Nums of j. Sorry, it should be next letter of j. If you don't get it, I will explain once again. Don't worry. This is nums. So finally, we have to return result. I'll check if it runs. If it runs, I will explain it. Explain the process. Hopefully, there should be no errors. Yeah, it is running. Let me submit it. I will copy the code and I will dry run this. Yeah, it is accepted. Yeah, it is greater than 85% and bits 94%. Now let me dry run this once again, because in the last part you may seem confused in this part. So I will explain it once again. Okay. I think you all can see this. Okay. It is not incrementing. Okay. In this, first what we are doing is we are taking this is taking the n, that is nums of size. We are initializing the result, that is n minus k plus 1, and we are initializing a stack and the next greatest element is right. And we are in this, what we are doing is we are placing a stack, and till the element which is not greatest to it, till it does not come, we will pop the element. And if there are no elements, then it would be empty, so we will assign n, else we'll assign the top of the stack. And this here comes the important part. So initially what we'll do is we'll set j is equal to 0, right? And we'll check. So I will come to this in the next part. So we will check while next greater of j is less than I plus k. So what I am doing is, in this case, wait, yeah, in this we are initializing the next greatest of I as the index, right? What I am doing is, you can see the next greater of j is less than or equal to I plus k. In this case 3, we can see whether 3 is less than or equal to I plus, the index of 3, that is 1, right? Whether 1 is less than or equal to I plus k. So yeah, it is 1 is less than equal to I plus k. Yeah, we can see this is from starting from 0, 0 plus k, that is 0 plus 3, right? Obviously 1 is less than 3. And then, so what we'll do is initialize the answer of result to the nums of j. And then what we'll do in the next phase, we'll check for the next index, and it will come to the next index. We'll check whether it will be 1 plus 3, that is whether j is less than or equal. So you can see j is less than or equal to next greater of j, that is, yeah, 1 is less than or equal to 4. So you may ask, it would go like, if it is the greatest element, it would go like that. But here it comes the element which is controlling all this. If j is less than I, j would be I. So what this states is, if for example, 5, 4, 3, 2, 1. In this case, 5 is the answer. For the next case, we can see it is 0, right? 0 is obviously less than 1 plus 3, 4, but it is iterating at the first index. Whether we'll check whether 0 is less than or equal to 1. Yeah, it is, j is less than or equal to 1. So in that case, we will initialize j as this index itself, and we will check the next greatest element in the array. So this is what we are doing in this part of the code. I think you all understood now. So that's it. Thank you.